Hello, Luke. Welcome to lesson 68. So today we're going to be talking about complex fractions. Now, recall we talked about this a while back. I'm going to give you an example here. If I have something like, I don't know, x over y divided by 1 over x, for example. All right? This is something that we would call a complex fraction because it's basically an expression composed of fractions within fractions, right? And if you recall, to solve this, we simply take the numerator fraction, x divided by y, and we would then multiply that by the reciprocal of the denominator fraction. So the reciprocal is just the inversion. We just flip-flop the bottom fraction. So the bottom fraction becomes, in this case, x over 1 instead of 1 over x. All right? And that's basically the setup. That's the important step to understand here, is you change the division to multiplication, and you take the bottom fraction and you flip-flop it. You find the reciprocal, and then you simply multiply as usual. So in the numerator, we have x times x, which is going to be x squared. And in the denominator, we have y times 1, which is, of course, y. And that is our solution for that particular problem. All right? So that is just a very quick review of what we have already learned with complex fractions. But today we're going to take this a step further. And let's say we have something that looks like this. Okay? So we're just going to look at this first expression here. And let's say that we are going to try to solve this, or try to simplify this, or divide this. Okay? You might see a problem right away. Let's take a look at it. If we were to kind of use the same method we used before, you would say, okay, I'm going to take the numerator and I'm going to multiply it by the reciprocal of the denominator, and that should give me my answer. But you're going to come across a problem in this case, and that is, how do you find the reciprocal of this? Do you see why this denominator is a bit tricky? How can you find the reciprocal? There's this subtraction, or you might say a form of addition, going on in this denominator. So can we just flip both fractions maybe and multiply the numerator by that? How would this work? That is the question, and that's what we're going to be talking about today. So the process that we're going to use to simplify this particular kind of a rational expression, and just as a quick reminder, as a side note, remember when I say rational, I'm referring to fractions. All right, we learned about our different number systems, and one of them was the rational number system, or the number set, I should say, the rational number set. And recall, that is any number that can be written as a ratio, or as a fraction. So 1/2 is rational. 3 is rational because I could write that as 3 over 1. 1 and 1/2, of course, is rational. I could write that as 3/2. All right, so anything that I can write as a fraction is considered a rational number. All right, so here, when I say this is a rational expression, just remember what that means. It means that this is made up of fractions. It's made up of numbers that are written as fractions. Okay, so whenever you see that word rational in your mind, you should think fraction. Okay? All right, but anyway, I digress. So getting back to the problem here, how would I simplify this? And it's really a two-step problem. The first step for these complex fraction problems is to add in the numerator. Add in the numerator and in the denominator. Numerator and denominator. Okay, so that's really the first step here. Okay, so we're going to take this numerator and just focus on that part of the problem. Okay, one thing at a time. We're just going to take that numerator and add it. So I have x over y plus 1 over y. This one actually works out really nice because the denominators are common. And remember, in order to add fractions, we need common denominators. So in this case, it works out really nicely because, yeah, we have common denominators. So we can go ahead and add the numerator, which in this case, I can't really get a number for it, but I can say that it's x plus 1, right? X plus 1. And that's over the common denominator, which is y, right? So if I'm adding these two fractions, I would end up with x plus 1 over y. Okay? And what we're going to do is we're going to write that up here. So that is equal to x plus 1 over y. Okay? Now, that's the numerator. And I'm actually just going to erase this now so that I've got a little more room here. All right, so that's the numerator. Now let's do the same thing for the denominator. We're going to take these two fractions and we're going to add them. So we have x over y minus 1 over y. And again, it looks really nice again because this is a common denominator. So in the numerator now we're going to have x minus 1 over y, the common denominator. Right? So that becomes the simplified version here. Okay? So, just backing up real quick. All we've done so far is done the addition in the numerator as well as in the denominator, which was step 1. We need to add in the numerator and in the denominator. So, the goal here is to get that numerator and denominator to be of the form that we're familiar with, which is kind of the rational form. Get it in the form of a fraction, one big fraction, instead of two separate ones being added to each other. All right? And the reason we want it in this form is because now we know how to handle this problem, right? Now it's very straightforward. We're right back to where we were before. Nothing new here. So here we have our x plus 1 over y, and we're going to multiply that by the reciprocal of our denominator, or our inverse of the denominator, which is y over x minus 1, right? And then we can multiply these out. So we end up with y times x plus 1. And in the denominator, we have y times x minus 1. Okay? Now look at that closely and make sure you understand how I got that. Notice the parentheses here. All right, this y is not being multiplied by just the 1. It's not being multiplied by just the x. It's being multiplied by this whole numerator. So we have to make sure we put it in parentheses here to show that this y is being distributed through. Okay? Make sure you understand that. Very important. Okay, now we can do a little reducing here, and we could have done it even in our multiplication process here. Maybe I'll just point that out. We could have recognized that we could do some cross-canceling. Y can go into itself once. Y can go into itself once. We could have eliminated the y's, and that would have just given us x plus 1 over x minus 1. Or if we didn't do it here, we could also do it in the second step here, which is just to recognize that we have, a product here of these two factors on the top and two factors in the bottom. They share a factor, which is the y. They can cross-cancel each other out or reduce each other out, and that's going to give us x plus 1 over x minus 1. So there, we have just simplified this rather large and a little bit annoying complex fraction over here. We've reduced it down to this right here, and it actually it's kind of cool because we were able to eliminate the y's completely. It's all the way down into just an expression of one variable right now. All right, so that worked out nicely. All right, so hopefully that makes sense. Maybe we should write the second step here, though. So add in the numerator and the denominator, and then we just simply divide. I'm going to say divide as usual. Divide as usual, which again would mean that we're taking this and we're multiplying it by the reciprocal of this, which is right over here, this section. Okay? Okay. All right. Let's move on. Let's try another one. 1 plus y over x. Why do I keep saying y for 1? I tell you what. 1 plus 1 over x. Excuse me. Divided by 7. Okay. So here again, we have a problem. We could just, we know that what the reciprocal is for the denominator in this case, but the numerator is going to be kind of a problem because here again, we don't have it in the form that we want. We don't have it in the single fraction form. We have this addition going on here, okay? Two terms that are being added. We don't want that when we have complex fractions. All right, so let's try to add this numerator. Step number 1, add everything in the numerator and add everything in the denominator. So in the numerator, we have 1 plus 1 over x. Now, this 1 could be written as 1 over 1, right? And now we need to find a common denominator here between a 1 and an x. Well, the common denominator is going to be an x, right? All right, or 1x, 1 times x, 1x, right? So we look at the first fraction, and if we're changing this denominator into an x, that means we multiplied the 1 by an x to get to the x. So therefore, we have to multiply the numerator by an x, which is going to give us an x over x, which totally makes sense because x divided by x is, of course, going to be 1, right? And then we have to add that to our other fraction, which we're not going to do anything to because it already has the x. All right, so this is just old review on trying to get common denominators so that we can add fractions. All right, now we can add the numerator up, and we get x plus 1 over the common denominator of x. All right, and now we've got our fraction. That's what we were aiming for. So this numerator becomes x plus 1 over x. The denominator remains a 7, okay? And now we're going to go ahead and divide this using our second step, which is divide as usual. So we're going to take the numerator, which is x plus 1 over x, and we're going to multiply that by the reciprocal of the denominator. Well, the denominator is 7 over 1, written as a fraction. So we're going to take the reciprocal of that, which is going to be 1 over 7. Okay? And now it's just a matter of multiplying things out. There isn't anything we can cross-cancel here. So we'll have x plus 1 times 1. Well, that's just going to be x plus 1. Okay? And then that is going to be over x times 7, which is 7x. All right, so that would be our final solution. Okay? All right. Now, this next one, why don't you try to do it on your own first, and then we'll do it together and see if you got the right answer. All right, so pause the video and give it a try. All right, let's see how you did. So, pretty straightforward here. We're going to add things. Well, you might first say we're going to recognize that there's a problem here, and that's the denominator. We have this addition, which is, remember, a subtraction is just another form of addition going on here. So we need to first add or combine what's in the denominator so that it's in one fraction. The numerator, on the other hand, looks good. That's the form that we want it to be in. So let's take this 1 minus 1 over x. What's that going to be if we combine them with a common denominator? Well, our common denominator is going to be x again, right? This is just like the last one, actually. And so what do we have? We have x over x for the first term right here. And then the second term, well, that's going to remain 1 over x, okay? And now we can, add these up because they have common denominators, right? So it's going to be x minus 1 over x. All right? So this denominator in this case becomes the x minus 1 over x. The numerator, that stays the same. Like we said earlier, that form is exactly the way we want it. Now we get to multiply this out, and we take the numerator and multiply it by the reciprocal of the denominator, which is x over x minus 1. And in this case, there is a little cross-canceling that we could do. The x would cross out the x, and we'd end up with 1 over x minus 1. All right? And that would be our solution right there. Okay. All right, let's try another one. Again, pause the video, try this one on your own, and then we'll do it together. All right, let's see how you did. So in this case, we have several problems going on here. The numerator isn't in the right form, and the denominator isn't in the right form either. So we need to do the first step, which is addition, combining these for both the numerator and the denominator. So let's take the numerator first. We have a over b plus 1. And we'll write that as a fraction, 1 over 1. Common denominator is going to be a b, right? So we didn't have to do anything to this denominator to get it to a b, so nothing needs to be done to the numerator. This denominator, we had to multiply it by a b, so we have to multiply the numerator by a b. And then that's going to give us a plus b over b. So that is our new numerator. And then we have that over our denominator. Well, we need to manipulate that a little bit too. So we have x over b plus 4 for our denominator. Make that 4 over 1. Common denominator is going to be a b. And again, our first term is going to be x over b. Our second term is going to be a 1 times b to be a b. And then that's going to make us multiply the 4 by a b. So we're going to get 4b. All right. Now we can combine the numerators, x plus 4b over the common denominator of b. So our new denominator here is going to be x plus 4b over b. Okay, so now we have it in the form that we want. 2 fractions. 1 fraction in the numerator, 1 fraction in the denominator. So now we're ready to go through business as usual. Let's go to red here. So what do we have? We have a plus b over b. And we're going to multiply that by the reciprocal here, which is going to be b over x plus 4b. All right, any cross canceling that we can do? There is in this case. The b would cross out the b. Of course, nothing can be crossed out here because these are sums. And so if you can cross out, you'd have to cross out the whole sum. And obviously, a plus b, that sum is not in this denominator. There's no a plus b over here. So we can't cross cancel anything out there, which then is going to lead us to the answer here. A plus b times 1 is just a plus b. And then 1 times x plus 4b is going to be x plus 4b. And that is going to be our solution. So hopefully you got that. If you did not, I would suggest pausing the video and starting all over with this problem. Don't look at what I did here on the screen and try it again by yourself until you can get this on your own. All right. Once you've accomplished that, you're ready for this next problem. All right. Okay, so this next problem, probably the trickiest that they'll throw at you, just because of the way that they wrote it here, the form that they wrote the problem in. So let's take a look at this one, see if we can figure it out. All right, so we're just trying to simplify here, and you might not believe this to be a complex fraction at first. You might say, I don't see fractions within fractions here. I just see one big rational expression, one big fraction, right? And therefore, maybe I'm all done. Maybe there isn't any simplification that I can do here. All right. Well, that's where negative exponents come in. Remember, negative exponents are kind of just another way of writing a fraction, right? If I have, b to the negative 2, remember, this is the same thing as 1 over b squared, right? If I move this b squared up into the numerator, it changes the sign of the exponent, and that's how I get b to the negative 2. So if I just kind of work that backwards, start with b to the negative 2, move it into the denominator, I have b squared, and now I have this fraction. So negative exponents, when you see them, you should think fraction, all right? It's just kind of a hidden way of writing a fraction. All right, so here we actually do have fractions within fractions. This a to the negative 1 is actually just, again, kind of a camouflaged way of writing 1 over a. Okay, and this b to the negative 1 is, again, just kind of a camouflaged way of writing 1 over b. And x would be 1 over x. All right, so we actually have several fractions all over the place here. So let's start by just rewriting this whole expression in terms that do not have negative exponents. So let's eliminate our negative exponents. And to do that, we're going to say a to the negative 1 is the same thing as 1 over a. Okay, now this 1 over a is being multiplied by this x, right? So 1 over a times x is just going to be x over a, right? So I might even just rewrite this as an x over an a. Okay? Hopefully you can see that in your head. All right, then if we continue, this b over 1, well, that's the equivalent of 1 over b, and 1 over b times a y is going to be a y over b, for the same reasons that we got x over a. Okay? In the denominator, we have x to the negative 1, which is equivalent to 1 over x. And now we have a problem that's very similar to our previous problems. We have a numerator where there is a sum going on of fractions, and we want that to be in a single fraction so that we can actually divide this out. So this is probably a good point to pause the video and try to continue this problem on your own, and then we'll see if you got the answer correct. All right, so let's see how well you did. If we have this numerator, we're going to want to try to combine the fractions by finding a common denominator, right? So maybe we'll do this separately off to the side. So if I have x over a plus y over b, what would be the common denominator for these two? Well, it's going to have to be ab, right? Because they both need to be part of the common denominator. They both need to be factors of the common denominator. So a over b is our common denominator. So what do we use to multiply a by to get ab? We multiplied it by b, so we have to multiply x by b, gives us xb. Here we had to multiply the denominator by an a, so we have to multiply the numerator by an a, gives us a ya, okay? And now I can write that all over the common denominator, and I'll write it alphabetically too. I just think it looks nicer. So bx plus ay over ab. All right, that is our new fraction. So that can be our new numerator over here. Okay, and then once we've got it to this point, we're back to business as usual, right? So now we're going to take that numerator, bx plus ay over ab, and we're going to multiply that by the reciprocal of the denominator, which would be x over 1. And there's nothing to cross-cancel in this one. And so our final answer is going to be x times, notice the parentheses, bx plus ay all over ab. Now, I could distribute this x through. That's fine as well, but this would work as a solution. Another way to write the solution, if I were to distribute that through, would be what? It'd be bx squared plus axy over ab. That would be another way to write that. Either way would be correct. All right, very good. So I think if you can work that one through, you shouldn't have any problems with your lesson for today. I don't think you're going to see anything worse than that. So we'll stop here for today. Good luck, and I will see you tomorrow.